Show that this integral equals 3e over 8 and use this substitution to find the exact value of this integral. So that's the question then. So let's have a little look at it. So here, this one, part A, I'll label it as I. So I equals then, okay, e to the something integrates to e to the something. But when you differentiate e to the something, e to the something differentiates to e to the something multiplied by the something differentiated. So minus 2 would come down. So we'll need a minus 2 underneath, won't we, for the integral. So this now, in fact, will differentiate to this term here, the integrand. So we just need to work out the values now. Okay, let's see what we've got. So it's e, this is e, to the 1 minus ln 2, top value, over minus 2. So that's the top value. Oh, 1 minus 2 log 2, isn't it? 2 log 2. Take away bottom value, put 0 in for x, and it's just e over minus 2. So that's equal to then. So we've got an e over minus 2 here in this 1 and here. So let's take that outside a bracket. But inside the bracket we'll have, because times with the indices you add, so we've got an e to the minus 2 ln 2 inside. And we've also got a, I've taken out a minus, so there's still a minus here, isn't there? And this would be a 1. Okay, so move the 2 up. So we've got e over minus 2. This 2 can be here, and we've got e to the log, and it becomes a power, and it's a quarter, isn't it? Minus 1. So this is equal to e to the log can cancel each other out. We get a quarter minus 1 is minus 3/4 over 2 becomes 3/8, which is what we wanted to show. Okay, so part B now. Let's let that equal I. So u equals tan x, we're going to use substitution. Du dx, tan differentiates to sec squared. Tan goes to sec squared, so we can use that in the substitution, can't we? So here I is equal to then. So it's the integral between 0 and pi over 4. Now we can use a substitution. So let's have a go. We've got root of u here, and then we've got, that's that bit there taken care of. We've got sec to the 4. Remember 1 plus tan squared is equal to sec squared. So we can replace this to the 4 by 1 plus tan squared, can't we, all squared, which is 1 plus u squared, that's u to the 4, taken care of there. Now we need to put dx in, well dx is du over sec squared x, so one of those will cancel, 1 plus u squared is the sec squared, isn't it? So we only needed one of those really. So we end up with this integral here, 0 to pi over 4. This will cancel with this, and we get u to the half, and run it through the bracket, it's u to the half plus u to the 5 over 2 when you add the powers, and run it, expand the bracket, du. Now the values here will change, won't it? So when x is 0, because we're going from x equals 0 to x equals pi over 4. So when x is 0, tan of 0 is 0, so u is 0. So that's fine. And when x is pi over 4, tan of pi over 4 is 1, so u equals 1. So we want to put a u equals 1 here, don't we? U equals 1. Okay, good. So that's nice. So that's equal to then integrate, raise the power by 1, divide by that number, plus u to the raise the power by 1, divide by that number. And that needs to be worked out between 1 and 0. Okay, so this is 2/3, isn't it? So it's going to be top value, put u is 1 in, it's just going to be 1, so this becomes 2/3, plus, and then this is u, put 1 in, you get 2/7. That's the top value. Take away, put the 0 in, and all these would be zeros, so we get that. 21s times by 7 is 14 over 21, plus times by 3, 6 over 21, isn't it? So that's 20 over 21. So that's the answer there, and it would be units squared because it's a measure of area. That's part B. Oh no, it was just an integral, wasn't it? Wasn't an area here in this particular example. So it's a value there.